When we look out at the night sky, it feels obvious that gravity is the master force. It holds planets in orbit, binds stars into galaxies, and sculpts the paths of black holes. Its reach is infinite, and yet its grip on individual objects is surprisingly weak. You can lift a paperclip with a tiny magnet against the pole of the entire Earth. Isn't it strange that the most cosmic of forces is, in fact, the feeblest when measured particle by particle? At our everyday scale, it is electromagnetism that rules. Every sensation, every chemical bond, every nerve impulse in your body comes from electromagnetic interactions. The structure of atoms, the shape of molecules, even the solidity of the chair beneath you are all consequences of electric charges and their fields. Magnets on your refrigerator, light from the sun, and the spark of static electricity in winter are simply different manifestations of the same force. Compared to gravity, electromagnetism dominates the intimate world of chemistry and biology. Doesn't it feel remarkable that, without ever noticing, you live inside a web, woven entirely from electromagnetic interactions? At the subatomic scale, another force emerges as supreme: the strong nuclear force. It binds protons and neutrons inside atomic nuclei, overcoming the immense electric repulsion between positively charged protons. Without it, atoms would fall apart instantly. The strong force is unimaginably powerful at distances smaller than a trillionth of a meter, but it fades away almost completely beyond that. This explains why we do not feel it directly in daily life. The paradox is clear. The most powerful force in the universe is hidden from our senses, while the weakest, gravity, dominates the stars. Doesn't this reversal of expectations feel almost like a cosmic joke? A lesser-known fact is that the hierarchy of forces is not fixed forever, but may unify at extreme energies. According to some theories, at conditions like those just after the Big Bang, the electromagnetic, weak, and strong forces may have been different faces of a single grand unified force. Only as the universe cooled did they split apart, with each taking its role at different scales. This suggests that the shifting dominance of forces is not arbitrary, but a consequence of how nature's laws unfold across energy levels and distances. Could it be that the universe itself chooses which force to highlight depending on scale? The hierarchy of forces shapes reality at every level. Gravity molds galaxies, electromagnetism shapes life, and the strong force builds the atomic nuclei that form all matter. The paradox is that each force seems weak or strong depending on where you stand. To an atom, gravity is irrelevant. To a galaxy, the strong force is invisible. So the question lingers: are these forces truly separate, or are they different expressions of one deeper principle that we have not yet uncovered? If so, perhaps the real mystery is not why the hierarchy shifts with scale, but why the universe hides its unity behind layers of apparent difference. Nature is governed by four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Each acts at different ranges and with different intensities, shaping matter and energy across scales. Gravity is the weakest, but has infinite reach, while the strong force is the most powerful but limited to the subatomic realm. Electromagnetism dominates chemical and biological processes, and the weak force governs radioactive decay. The relative importance of these forces depends on the size and context of the system. At one scale, a force may seem negligible, while at another it dictates everything. This hierarchy is the foundation of the paradox. The weak force is irrelevant in daily life, yet it powers the sun through nuclear fusion. It is like four musicians playing at different volumes and ranges. Sometimes one dominates, sometimes another. Gravity rules the universe on the largest scales. Though it is the weakest force, its infinite range and universal attraction mean it accumulates across immense masses. Stars, planets, galaxies, and black holes owe their structure to gravity. No other force can compete with its dominance in shaping cosmic architecture. Its persistence allows it to sculpt the evolution of the universe over billions of years. On cosmic scales, gravity alone sets the stage. Without it, no stars or galaxies would exist. The Milky Way's spiral arms and central black hole are maintained by the gravitational pull of billions of stars. Gravity is like a whisper that becomes powerful when repeated by an entire crowd. At the level of atoms, molecules, and organisms, electromagnetism is the dominant force. It governs the structure of atoms, chemical bonding, electricity, and magnetism. Biological processes, from nerve impulses to photosynthesis, depend on electromagnetic interactions. Unlike gravity, it can be both attractive and repulsive, allowing complex structures to form. Its range is long, but charges tend to cancel, which is why we don't notice it at cosmic scales. In our daily world, however, it overwhelms gravity's influence. This makes electromagnetism the foundation of chemistry and life. A fridge magnet easily resists Earth's gravity, showing how strong electromagnetism is compared to gravity at small scales. It is like a single violin playing louder than an orchestra when listened to up close. At the smallest distances inside atomic nuclei, the strong nuclear force dominates all others. It binds protons and neutrons together, despite their mutual electromagnetic repulsion. Its strength is immense, but limited to ranges smaller than an atom. Without it, nuclei could not exist, and matter would dissolve into particles. The strong force holds the building blocks of the universe together with unyielding grip. On larger scales, its influence vanishes because it cannot act across distance. Its paradoxical nature is absolute strength confined to invisibly small domains. Protons inside a nucleus stay bound together only because of the strong nuclear force despite their intense repulsion. It is like glue, so powerful that it binds instantly but only works if objects are pressed extremely close. The weak nuclear force is less familiar but crucial to the universe. It governs radioactive decay, neutrino interactions, and processes inside stars. Though weak compared to other forces, it enables fusion in stars, making sunlight possible. Its range is even smaller than the strong force, but its effects accumulate in cosmic phenomena. Without the weak force, heavy elements would not form and life as we know it would not exist. Though invisible in daily life, it underpins both stellar energy and nuclear transformations. Its subtlety belies its importance. Beta decay of neutrons occurs through the weak force, changing them into protons and releasing electrons. It is like a quiet backstage worker whose actions make the entire play possible. The hierarchy of forces shifts with scale because each force has a characteristic strength and range. Gravity is weak but cumulative, becoming decisive across massive objects. Electromagnetism is strong at small scales but cancels out in large neutral systems. The strong force dominates only within nuclei, while the weak force acts on subatomic transformations. Context determines which force governs the behavior of a system. What seems irrelevant in one realm may be fundamental in another. Scale is the key to the shifting dominance of forces. Gravity binds planets into orbits, but electromagnetism shapes the chemistry of their surfaces. It is like different rulers taking charge of separate kingdoms, each supreme within their own borders. Humans perceive forces differently because of the scales at which we live. We feel gravity daily because Earth's mass makes its effect constant. Electromagnetism is invisible, yet it runs through everything we touch and see. We rarely notice nuclear forces because they act inside atoms beyond our senses. This bias shapes our intuition, making gravity seem universal when in fact it is often the weakest. Our perspective distorts our sense of the true hierarchy. A small magnet lifting a paperclip defies Earth's gravity, yet humans still think of gravity as the strongest force. It is like thinking a candle is brighter than the sun just because it's closer to our eyes. Physicists seek to unify the four forces into a single framework. Electromagnetism and the weak force are already combined into the electroweak theory. The strong force is described by quantum chromodynamics, but its unification with electroweak theory remains incomplete. Gravity is the hardest to unify with the others due to its fundamentally different nature. A complete theory of everything would explain why forces differ in strength and scale. Until then, the hierarchy remains one of nature's deepest puzzles. Grand unified theories predict that at extremely high energies, the strengths of forces may converge. It is like four rivers flowing separately on the surface, but joining into one source underground. The paradox is that the strongest force is hidden at the smallest scales, while the weakest rules the cosmos. Gravity seems supreme in space, yet loses to electromagnetism in your kitchen. The strong force holds nuclei together, yet vanishes beyond an atom. The weak force drives stars, yet remains invisible in daily life. Each force is both essential and limited, supreme and humble, depending on perspective. The hierarchy of forces is not fixed but contextual. It shows that strength in physics depends entirely on scale. A magnet on your refrigerator overpowers the pull of the entire Earth, yet gravity controls galaxies. It is like a king who rules a city, a mayor who rules a town, and a family elder who rules a household, each powerful only in their own domain.